Hello, I'm Keith Miller, GIS Manager at Kāpiti Coast District Council, and I'm going to be talking to you today about the HBA project and how we use Python notebooks to make the project run easier. I'll give you an overview of what HBA is and what it stands for. I'll talk about the HBA modeling process, what Python notebooks are, and give you a quick demo of them too, and then I'll explain how I use them in the HBA project. So what is the HBA? Many councils had to go through the HBA process last year, and it's planning for urban growth. And for us, that means how many buildings or dwellings could be built in Kāpiti over the coming years, and also where could they possibly go. This is potential dwellings. So we generated two models. One was the complete redevelopment model, which imagines a clean slate and there's no houses built at all. Where could you put houses there or dwellings there? And also the infill model, which is we've got the existing houses. Which subdivisions could you do to actually to add houses into back gardens and so on and so forth. We use many different GIS data sets to do this, such as parcels, QV data, the building outlines, district plan data, and manipulated these in ArcGIS Pro. And we also use City Engine for creating 3D models of which buildings could be generated based on the district plan rules. I'm not going to be going into City Engine detail just in this talk though. So here's a diagram illustrating the HBA process. There's three main chunks that are shown in blue, and the inputs are shown in white. The first stage was to collect and process input data, and this was the largest step for us, well, most complex at least anyway. And so there's about 50 odd geoprocessing tasks that we used ArcGIS Pro to transform the input data into data that can be passed in Engine, which is the second step. Then we did modeling the HBA rules in City Engine to generate the 3D models. And the third step was post-processing, also in ArcGIS Pro, of the City Engine output to create 3D web scenes and spreadsheets as well. Now, all of this could be run manually, and especially the collating and processing of input data, especially. Well, not especially, but that's the part that all could be run manually, but the Python notebooks make the first and the third stages much easier to do. And I'll talk to you a little bit about that later. But first of all, what are Python notebooks? They can do that. I believe these Python notebooks can do many different things, but for me, what they allow you to do is to run snippets of Python code and then store the results within an ArcGIS Pro project. And so you don't have to write the code from scratch. You can actually run the tool manually within ArcGIS Pro, and then you can copy the Python snippet and paste it into a notebook, and I'll show you how to do that in a minute. Now, there's two real benefits I can see of using notebooks. First one is that the code can be rerun easily, and quite often your input parameters will change, and if you've got them set up correctly, the notebooks, then you'll be able to change the data and then just run the model or run the notebook to effectively run the model. And if you add comments to the code, then what it actually acts as a form of documentation so that another person can pick up the project or the notebook later on and understand hopefully what was going on, how the model was set up. So now it's demo time, and let's hope this runs successfully here. So, okay, what I'm going to do is I'll just hide myself a little bit here, and what I'll do is, first of all, I'm just going to run a simple GIS processing tool. And all I'm going to do is, first of all, I'll just remove this one here, delete that, and I will just going to drag this parcels data into the map. So what I'll do is now I'll actually just I'm going to make a copy of this parcels data. So I'll just move my way over here and then go into geoprocessing. And what I'm going to do is create a copy of this. So I'm just picking parcels here. That's the parcels data set that I've just dropped in. And it's just going to create a copy of it called parcels copy also in the demo geodatabase. So I'm just going to run that. And you can see it's done it over here on the left. Just untick this. It's the same color, but that's fine. So you can see that the data is there. And also I'll show you it in the catalog, and it's just put parcels copy back into there. So that's all well and good. But what if we wanted to do that using a Python notebook? So first of all, I'll just open a new notebook. So if you just click on the Python button up here, it creates a new notebook for you. And this is where you can put in the code. So how do we get the code from the copy command that I've just done? So if you go into history and you go to recent one, and you can just double click on it. First of all, you can see this is the one I just ran. And then if you right click on the run button, you can click copy Python command. And I'll just paste that into here. And there you go. And it says ArcPy, which is just the Python library, and it's running the copy features. That makes sense. It's taking parcels as the first parameter, and then it's using parcels copy. It's giving the fully qualified string or full path of where that is, and then some other parameters as well. So what I'll just show you here. Actually, I'll just show you how you can find out what all those parameters actually mean. And if you click, this is really handy. If you click on the question mark on any of the geoprocessing tools, it opens up the documentation for that particular tool on the web. So if I just copy features, and I can see that the first parameter is in features, the second parameter is the out feature class, and then a bunch of other parameters that at the moment I don't really care about, and I'm just leaving those as default. And whenever you're running tools within Python or Python tools, if you're not changing any of the parameters towards the end of the of the parameters, then you can actually remove them if you're not making any changes to them. So that's what I'm actually what I can do is well, first of all, I'll actually just run this to check and to show you that it actually does the job it's supposed to do. So I'll just remove this parcels copy from the table of contents, and I'll delete the parcels copy. So we're just left with the original now. And if I click on run, then what it'll do, it'll actually, should see it appear here, that's parcels copy, and you can see it's hopefully appeared in the demo geodatabase as well. So that's created that. So that was nice and easy. There's a few different things we can actually do to make this code a bit more readable. Now you could just run it as we've just straight copy and paste, and that works nicely. But what happens if you actually change the name of the original or the name of the place where you want to copy it to? So there's a few different things here we can do. I'm just going to type in some commands, just easier to do this, but I'm just going to set up the ArcPy workspace. And that the workspace we're working in is this demo geodatabase. And I'm just going to grab the path to that. And I'll just paste it in there. That's great. And what I'll also do is I'll just just create some variables, one called parcels in. I'm just going to call it, give the value of parcels, which is the name of the feature class within this workspace. So when I think now I can refer to just the parcels, and I don't have to on the parcels out, and I don't have to refer to the fully qualified path. So if I put parcels out equals parcels out, then it's just referring to both everything within this demo geodatabase, because I've set up the workspace there. So now what I can do is I can actually make us use variables here as well. Parcels in, just replacing these parcels out, and then I can actually remove all of these extra parameters because they were default and I wasn't changing them anyway. So if I'll just remove this again and also remove this. And then if I rerun this now, it should do the same job. Great. So it's now created the parcels out again, which is called parcels out is called now instead of parcels copy, and has also created something called parcels out there. So that's just a very simple illustration of how you can actually create your Python notebook. Now, what I find is it's really useful to break up you've got a few different, you can actually have different code blocks here. And I find it really useful to keep the code blocks generally fairly small so that you can actually document them, and also you can run snippets of code one bit at a time in case something breaks. And then if it does break, you can work out why it's broken or where it's broken. What I'll show you as well is how we use this in the HBA. So we've actually got 8 different Python notebooks for the HBA, and also for the input processing. And then we've also got a couple of ones for the third blue box I showed you in the diagram earlier on, which is post city engine processing. But I'll just show you the first one first, and I won't go through this in great detail. But you can, so the first one I've got here is quite complicated, but it's just setting up a bunch of parameters, just like I did before. You can see I've set up the workspace just like I did in the previous example I was showing you. And then this is just assigning a bunch of variables and file names. Then we actually get into the real geoprocessing. And in fact, this first one is pretty much exactly what we're just looking at there now, which is making a copy of the original parcels data. I've added in a comment so I know what's going on. And I'm doing the same thing as before. I'm copying, using copy features and taken from the original parcels into a copy of it. So never amending the original data. So that means that if I rerun the model, I'm never actually not overwriting anything in the original parcels, so we can always just rerun the model again and again. And so I'm just going to scroll down here, and you can see different geoprocessing tasks that are being done here. And so this is yeah, so it's pretty complex. This particular one is quite complex to run. So, but if I want to run this, then I just click on the run button for the first one, then click on the run button for the second one, and so on. And then that will actually step me through the running of the model. And let's just have a look at my notes and see if I've missed out anything here. But yeah, I mean, I probably ran these notebooks about 20 times each because the inputs kept on changing, and it was just invaluable to me that I didn't have to rerun the tools manually. First of all, I wouldn't remember what order I ran them in, or it would be difficult to document. But if I run so this just made it so much easier. I could just change a few things in the input parameters or tweak the Python notebook slightly, add in a new geoprocessing task in the middle of between different ones that I've already run before, and then run it off in the beginning, and it would actually generate this the data that was due to go into the city model. And then also in the post-processing scripts, it was the same idea. You take the city engine data and create 3D models for web scenes, and also to output to a spreadsheet. So that is an illustration of how I used ArcGIS Pro Python notebooks on the HBA. I found them really, really useful, and I'm going to be using them in many different projects in the future, hopefully. I hope you enjoyed that talk, and I'll say goodbye. Cheerio.